Hello, Patrice. And hello, everyone else in the room. I cannot hear you. I don't know if...
Okay.
No.
I was just,
okay.
Yeah. You haven't started to record, or? No, I put stop recording here.
I just started recording. Yeah.
Okay. I am just trying to finalize the
yeah
presentation, the project.
Yeah.
So
no, maybe
it will be uploaded before 11. So tell them that I will join after the coffee break to explain. Take 10 minutes to just yeah.
Very good.
Anything else?
I will start, or I can. I think it's small as 10 o'clock now, and I think I can start with some maybe a review of the yesterday's exercise that I also showed to you, and then answer some of the questions actually that were posted on Canvas, and then I think we'll see if there are more questions coming up.
Okay, what we did last week with Roberto is that the questions here were cleaned up, and then there were only like 8 of them. So you get them today by email, you fill in, and I will upload them. And the questions and answers on Canvas, you can answer today and record it, and then later we also can put in text. But for that, after all my day meetings around 4 o'clock, maybe I can have a word with you, like a Teams or something. Do you have time?
Yeah. No, I think, I mean, I made a small presentation, and I can show it to you all. And then if there are remaining questions, of course, we can also solve them later. I
will not join you. I will stop soon, but because I have to finish the project, and at the same time on my other computer, I have to join another meeting. So people are waiting for me at another meeting. But yeah, that's the way it is. Yeah. So I remember to start recording.
Yes, I have, or the meeting is already recorded now. Yeah.
Okay. Thank you. Bye then.
Yeah.
You have to check the questions yourself. I'm sorry, I will not be able to help you.
No, that's fine. Yeah.
Okay, thank you. Bye. Yeah.
Yeah. Bye-bye. Okay. Yeah, welcome everyone. There were some more people popping in, but I think we can start in a way. Yeah, the program for today, I will go through this small exercise I posted yesterday. We can see how it was solved. Then I can also discuss some of the questions. And at around 11, then Patrice will tell something about the project. Some details about that. So if you have further questions, please either write them in the chat, or as it was also last week in the Canvas, on the Canvas page here under discussion. I just had a look, and I copied actually or recorded some of the questions from there. But we can maybe start with a small exercise I showed yesterday, so I hope you can see my screen. It was about timber beam that was notched at the support, here with a tapered notch, with an inclined notch. The geometry or the length of the notch is given, but we don't know, or we want to find out the actual notch height, so that the notch itself and the bending of the beam are at a maximum, so in equilibrium. So that's a bit maybe an optimization problem, but maybe you can also get an idea what effect actually the notch has on the reduction of strength on the beam and when it becomes decisive or not. So what we can do, of course, or one of the challenges, or of course the loading here in this example is not available, or we don't know that loading QD. We'll just switch off my camera maybe to reduce a bit the data traffic. So what we first can do is, of course, to design the bending of the beam so that, yeah, it's at a maximum. So we can calculate the bending stresses in midspan, and we can verify it against bending strengths. That's no big issue. We have a C30, so a solid timber with a bending strength of 30 Newton per square millimeter. For the solid timber, the partial factor is 1.3, and the K mod for the medium load duration is 0.8. And so with this geometry, we find a maximum line load on the beam of around 5.6 kilonewton per meter. So if the load, the design value of this load is smaller than this 5.6, we actually don't, the bending strength is satisfied. And now we want to have a look at the notch capacity. So as you remember, we have this equation here that we have to verify at the notch corner. So on the one hand, we have the shear stresses acting at the in the reduced cross section. So the H effective is the reduced beam height. Maybe I can do this like this. Yeah. Let's see if that works. It would be a rectangular notch, and if we have an inclined notch here with an inclination of I. So that's our reduced H effective. So the reduced beam height, and here on the other side we have actually the full beam height of H. Sorry that my writing is not so beautiful, but I hope it works. And now we can actually think about, or we can we don't know the notch height, or we don't know which how big actually the notch can be here in this part. So we have to try different values to actually find the right height of the notch. And what we can do is to actually solve this equation with regard to this notch ratio alpha. So that is here on the left side when we calculate the shear stresses in the reduced cross section. but it's also included here in this value kV. So this reduction factor of the shear strength in the beam. And yeah, we can fill in all the values we know. We know the load, that's this 5.6 kilonewton. We know the K crack for the solid timber beam is 0.67. The width of the beam, the height of the beam, so the full height of the beam, this is all known. And also the K mod, gamma M, and oh sorry, that's supposed to be the characteristic value of the shear strength. This is also known. That's a 4 Newton per square millimeter. And we end up that actually this term alpha times kV shall be or should be equal to 0.616. And now we can yeah, try to calculate it. Of course, it would be a bit too work intensive to calculate it by hand. So we can actually put this into an Excel spreadsheet where we actually yeah, can put in all the values. We know here this value for solid timber, it's Kn is equal to 5. So we have this material strength value available. Actually, we know the x, so the distance from the center of the support. Let us take it here. That's the value of x in this approach. So we can put this in, and the inclination, if we have a fixed length of the inclination, of course, the inclination will vary depending on the notch height. So it will be kind of sorry. So that's yeah, the notch height divided, or the notch length. If we say it, the length of the notch divided by the height of the notch. So that we can use these values, and we can now put this into an Excel sheet, and we actually can first of all calculate, for example, the value or this reduction factor kV, which is as itself already interesting to get a feeling how the capacity of the beam is actually influenced by the notch. And we see that, yeah, starting from 1, so that's the full cross section without the notch. If we increase the notch for a certain period, nothing happens, but then this reduction, yeah, becomes quite drastic, and yeah, maybe with 20% notch height, or somehow if the reduction in the cross section is 20%, we have already we can only account for 60% of the shear capacity. So that's quite a dramatic reduction of the shear capacity, of course. So maybe a take-home message from this graph already is, yeah, try to avoid any type of notch because it will reduce the capacity quite drastically. We can now, yeah, in Excel just put this together here, alpha times this reduction factor, and we are looking for the situation when this is equal to 0.61. So that's this brown line here, and we can already, or it follows the same trend, and we can see here already somewhere in this direction this value is 0.61, and if we calculate it more precisely, we find out that yeah, with the alpha value of 0.86 or 87, actually the notch capacity is just at the point so that the capacity of the notch and the capacity in bending of the beam are both at the maximum. And we can, so that's 87% more or less may this reduced cross section, that's alpha alpha times h is equal to this reduced cross section, so we can actually calculate the height of the notch, and that's just around 33 millimeter. So the notch reduction is rather low, just around 15%, and then the bending or the notch becomes decisive if the notch height would increase further. So that's quite small, I would say. So with this small example, I hope you got you have a bit of feeling what the notch means with regard to the strength of the beam. So with any type of notch, you will have quite a drastic reduction of load carrying capacity. I don't know if some of you have tried maybe some of these or have I see some questions actually. Okay. If anybody of you have tried any of these calculations, but I think it's should not be a big issue, but I think it's maybe interesting to just play around and try this by yourself. So I would then maybe start with some questions that were posted on Canvas, if you agree, or if there are some other questions. I think you will be able to see my screen now. I actually put some of the questions here in a small PowerPoint, so then we can also see them and discuss them more in detail. There was a question about actually a beam, or there was a picture given here. There was a beam, a solid, or this probably floor beam, solid timber as it seems to be, with a quite big crack from drying, so that you can even stick a pen inside. And of course the question was, well, how that would be effect if you would have holes in such a beam, how that could be possible. And of course the question, what meaning or how external reinforcement would affect this. And of course, well, that's maybe a special question or a tricky question. Well, one or there are three maybe answers to these questions. Of course, you should first of all avoid holes in solid timber beams, especially if they are prone to cracking in a way. You should repair the crack first of all, if that's necessary. And then I would say the best option for this type of situation would be also internal reinforcement, for example, by screws, fully threaded screws. They are quite, I would say, ductile, so they are could also go through the crack and reinforce the crack even further. Maybe one comment with regard to the solid timber beams is that well, in maybe especially older constructions, you had the solid timber beams here with a pith, and then you had the growth rings somewhere going around, and then well, depending how the beams were produced, if they were maybe also very large, of course you had a certain initial moisture content, and then in the structure the moisture dried down. So it's extremely common to have in solid timber beams in old structures to have here cracks just in the middle of the cross section. So you actually have the beam split in half, and often, I mean, like the beam also looks a bit distorted. So you have like something like this. If you have seen the old structures, so you have kind of a remaining beam cross-section geometry that looks like that. Of course, if you want to now design this beam in shear, of course you should, I mean, if you repair, maintain an old structure, you should only account for this width in shear if you want to design the shear capacity of such a beam. Alternatively, of course, you could start to reinforce, repair this crack if that's necessary in order to restore the larger beam width, or the reactivate the entire beam width. But that would be that's the common issue. And of course, for this solid timber beam, which is maybe even the surface is not straight, of course, the external reinforcement that's not possible. So you have to have a smooth surface to be able to properly screw press the reinforcement on that beam. So the best would be here to use some internal reinforcement, some fully threaded screws that can be drilled through this beam. Maybe I could say some words also with regard to the repair of cracks. The repair of cracks is mostly interesting for larger beams, larger cross sections, glulam beams, for example, where you have maybe some cracks, well, from moisture variations or from tension perpendicular to the grain, and where you want to then restore the entire load carrying capacity of the entire cross section. So there are procedures for actually filling these cracks. So here you see, well, it's artificial crack in that sense, but to show the procedure that's can be very illustrative. So first of all, one has to clean the crack. So one has to clean, of course, all the dust on all the dirt that is in the crack in order to reinforce it properly. Then there are some systems where actually the surface of the beam is closed here with a certain adhesive, so that to create a smooth surface and to actually close the crack from the surface. But that's of course not yet the full repair, because after the closing of the surface, actually there are some small holes are drilled in a distance of maybe 15 to 30 centimeter. So every 20 centimeter around there's a hole drilled. You see here the example here at this position, kind of the crack is holes are drilled to the crack, and then actually the crack is injected with a special adhesive for repair. So you start at one hole and you press the adhesive in until it comes out at the next hole, and then you can actually close this small hole where you inject it with a small plug, so to seal the crack that was just injected. And so like this, you actually continue from one hole to the other, and you can inject the entire crack to rebond the two beams together. You can, or for larger projects, you should also check maybe with a drill core in some locations if actually your entire crack was also sealed, and you could even do some shear tests on these plugs in order to see if the load carrying or the bond strength is satisfied. Of course, this hole, then you have to again fill. So you will put in another timber plug there, and of course bond it properly so that you have restore the capacity of the beam. Maybe I could show one small some few slides on that. I have to apologize that the slides are actually in German, but maybe you can actually get an idea what was the issue in this repair project. So you see here, I think you can see my mouse, or I hope you can see it, maybe not. Anyway, you see here the a school project from the 1970s. A bigger structure with a different roof, larger roof areas and larger hole areas. And in one of the hole areas, actually there were some glulam beams in the ceiling. You see here like a cut through the section, so you hear some larger roof beams in the structure. Yeah. Okay. Thanks a lot. Well, in this project, they actually at a certain point they figured out that there were quite some substantial cracks when they inspected the structure in these roof beams. So you see here some cracks. Sometimes they are running through the lamellas, so it seems to be some drying cracks, but sometimes the cracks actually also run within the lamella of the, or within the glue line of the beams. So that's of course quite alarming. If the cracks run nicely in the glue lines, that could be a indicator that actually the glue was not maybe suitable at the time in the 1970s. There was maybe the producer used the wrong glue or did something wrong in the production. And you can, of course, or you should, if you do this maintenance project, you should record all the cracks and make a plan or somehow write down their position so that you can monitor them if they are increasing or if there was maybe just at a small location. So what they ended up with was these drawings with the plans with all the cracks in the beams with different depths. Some were more like superficial, but some were really going through the entire, or probably through the entire. Then they also did some shear tests on the beams, on the adhesive, to see how the shear strength of the adhesive is, and it was not so nice or not so adequate, so they had to do some repair works. In this project, they of course had to do some emergency measures first of all, but what they did is to reinforce. Reinforce actually the beams with internal reinforcement, so with reinforcing or threaded rods here in the region of the support. So there was quite some massive reinforcement, I don't know, it was diameter, I think diameter 16, like threaded rods that were like yeah, drilled into these beams somehow as a shear reinforcement, and in addition, like additional lamellas were added to the beam to create a tension cord for this beam. So you see it here. There were some tests also done in the laboratory to reinforce the beam here in tension, and here in the outer parts actually the screw reinforcement was placed. So you see how that was produced. It's of course quite a bit of major work to glue these lamellas to the beam and to create sufficient bond action. And then here you see how the rods were drilled in. First, the hole was pre-drilled, and then the rods were threaded into these beams to restore the capacity. So that was maybe one example where a larger beam was reinforced. Of course, for this smaller beam, maybe some internal fully threaded screws would be sufficient. But of course, you should be, or holes in this section are not really recommended, and external reinforcement neither. And there was a second question about like notches in central positions of the beams. So you could imagine that you have this you have this continuous continuous beam here running through. You have some support elements, columns or so, and you want to create, or it's a plan to create here the notches over the supports. Of course, here compared to the example that we showed yesterday with the end notched beam, where you have the if the notches at the support, of course you have you have maybe high shear stresses, so your shear stresses are maybe maximum, but your moment is probably 0. So that's the situation I showed to you. But in this situation, of course, you would have the high bending moment over these supports. So you have a combination of moment and shear force acting together at this support. So what's how to apply this approach there? And in addition, it's also here you can imagine that while there's some tension perpendicular to the grain induced both from the moment and from the shear force. In this case, now if one would imagine how the stresses would occur, if we just look at the shear force, one would also imagine that actually that there's some opening that there's some opening of the crack from the moment, but from the shear force, but the moment would actually create more some maybe well, closing. I don't know if it would be directly closing, but it would create actually some compression maybe here in this part. So the question is if that's beneficial and if that could be actually considered as a end notch at the upper beam part. So that's a big question. If that is well, if that could be applied, or if it is a notch at the lower part. Well, first of all, I have to unfortunately say that this situation here with a central with the central notches is not really covered by the approach that is given in the handbooks and in Eurocode. So you cannot directly apply this approach to these situations. However, what you could do is, of course, to maybe get a bit of understanding and try to get around the situation. But first of all, what you should consider is, of course, avoid the notches whenever possible, because they will create quite some reduction of load carrying capacity. And well, at a certain point, you will have a crack or you will have some troubles there. So whenever possible, try to avoid it, and you will free yourself from a lot of trouble. The second point is to reinforce it if you still need it. So you could, for example, of course, apply here maybe some external reinforcement, so to reinforce it, the area in a broader sense, to carry with the loads, the moments also in some plywood, to really guide the forces around this notch. And of course, if you are very certain what you're doing, you could also carefully design these situations. Maybe some comments to these different types of notches. Here you see an example where maybe notches could occur in this beam in a single bending, and actually the approach that is given in Eurocode, you could apply it also to all these situations, considering that, for example, for this type of notch here in the center of the beam, actually this whole length would be this notch length x that you apply in the approach. So you for designing this type of notch, you would disregard this whole area and just design the notch to this point. Of course, it's extremely inefficient, and you will end up with extremely low load carrying capacities. But that's actually also facing or showing the problem when we have these central notches. A different approach, well, you could get some ideas from actually an American wood handbook, where this type of approach is given, including the moment and the shear force. So you could design also notches in the center position of a beam based on the local moment and the shear forces at this position. Of course, that's maybe just to get a feeling. I would not recommend to apply these equations for designing it, because what you will end up is actually that you will have a low capacity, and well, ideally you find other measures to get around this situation. I would not use this analogy to say that the compression here from the moment is not sufficient to I would say counteract these tension stresses perpendicular to the grain for this situation. So I would say here that this analogy should not be made. So you rather should account for the tensile stresses perpendicular to the grain also for this situation. You could account for the maximum shear, or apply the shear stresses or the shear force here in this situation, and actually modify your x, I can maybe, if there's a strong need to design this, I could maybe give you some additional remarks in personal communication. I don't want to kind of trigger any wrong design here at the moment, but yeah, try to avoid it and reinforce it, and yeah, if definitely necessary, there maybe are some solutions, but they won't be beneficial enough. Another question was about this situation of this notch, or I mean, yeah, this is a beam end where you have actually a lower notch and an upper notch, and of course it's a bit the question what how to deal with this type of geometry, how to consider the design. I don't know if, or I don't know the details of this type of notch. Well, there are yeah, different possibilities. One easy possibility is to look if that's supposed to be like a mortise and tenon connection. Actually, in the German national annex of the Eurocode, there are some design recommendations. It's called Zapfenverbindung. I don't know what the Swedish term is for this type of traditional carpentry joint that was or is maybe used in more historic structures. So you have here some yeah, the drawing of this was mostly in timber frame or like old half timbered structures. You could find it for solid timber beams, where you connect, yeah, a beam with a column or some other secondary or primary structures. And what you're doing is to have here these two, or you can calculate the capacity based on these two parts. So on one hand, you verify the notch capacity here with this factor. So you have here again the B effective, the reduced cross section here. You account for the full or up to the top the cross section. You have here this reduction factor KV that we've seen before already, and you have here the an additional yeah, reduction factor KZ that is here considered especially for this situation. And with that, you can actually calculate your capacity here of this mortise. So you can, in this situation, apply the entire beam height. And in addition, of course, you have to verify the compression perpendicular to the grain in this for this tenon here. There are also some geometric limitations. So for beams up to 300 millimeter, this is possible to apply. So it's really like traditional yeah, carpentry structures or connections in old structures. So that might help you maybe with some detail on that. I don't know if the details or what the details here in this structure are, but there could be maybe a solution to. There was also another question of like a hole in a T section. We said that in a rectangular cross section or normal beam cross section, we are supposed to have the hole more or less in the center of the beam axis, so to have a yeah. To reduce the loads or to design it like this. If you have this T section, of course, your neutral axis will be somewhere here. So it's a question where, well, which neutral axis to account for in the design of the whole. The answer is that we don't really have a proper, or there's no answer to that, no real answer so far. I would say if you have no composite action, of course, this lower beam is considered individually. If you have a full composite action, I would still consider some minimum distances here from these upper and lower regions of the beam. But with regard to the well, stresses, yeah, well, one should maybe place the hole more in the direction of the neutral axis. If there's incomplete action, well, we don't really know. Yeah, maybe it would be more wise to consider this lower beam here as an individual member for this situation. But yeah, if you have this situation, of course, maybe a bit more detailed analysis should be done to see how big the composite action is. For example, in timber concrete composite, if there's not full composite action, I would put the hole rather closer to the neutral or the center of this lower beam compared to the neutral axis of this combined cross section. But yeah, that's maybe some comments. There was I just see that there's one bigger, or there's some question in the chat. I will quickly have a look at them. I'm not 100% sure if I get the answer or the question properly. So there was a question with regard to the first question, with crack in beams, would you also account for an effective web thickness when verifying the moment capacity? Okay, yeah, I mean, so in this situation, of course, you have a, yeah, it's maybe like a I-beam cross section could be considered. Well, for the to verify the moment, well, I mean, it depends a little bit. I mean, if the crack or if there's some severe damage, yeah, maybe one should really reinforce these elements. So if there are doubts that they will actually remain intact. If the crack is maybe just 1/3 or maybe not complete, or if there's some, if the interaction of the both beam parts can be expected to hold together, I would actually calculate the moment with a full cross section. So I would not consider any composite action in this case. So normally, yeah, this actually the good thing is that the beam cracks at the part with the lowest strength. So one could assume that the remaining cross section will be a bit stronger than this cracked cross section. So for the moment, I think it's fair enough to consider the entire cross section for this situation. But yeah, for the shear, since highest shear stresses are in this location, of course, they are concentrated in this part, and there we have to be more careful. So there's another. So let's see. I mean, maybe there was a comment here also to this situation. Of course, if you have a well, I mean, most of the, or for the, at least for the GLUDEM, most studies, or of course, it is assumed that the material is kind of homogeneous in a way. So especially for if you have a like a GL, the second, in this case, if you have a for example, a GL 30C, of course, you have like in this part, in the lower part, you have actually a very good material, and in the central part, you actually have some worse material, or like not so good material in a way. So in order to achieve this GL30C, you assume that yeah, you have high bending stresses in the top and the bottom. There you need the high tensile capacities of the wood, whereas in the central part, at the support, you have the shear stresses, but in the normal region, actually the central part is not stressed so much. So by creating here this notch, of course, you cut away the good wood here, maybe in the region where there are also expected to be high bending stresses or compression stresses even. So it's definitely not good to weaken the beam or cutting away the best lamellas of the beam in this situation. So yeah, really avoid this type of this type of notches. That's really true. Maybe one quick answer here. This, I mean, here in this situation, this FC90C is actually the compression strength perpendicular to grain. I think that if that was an answer. So we verify here the compression in this region here as well. No, you can actually, you don't have to watch this lecture. You can also watch it afterwards. But yeah, in some minutes, Patrice will present also the homework exercise. There was a question with regard to fire. Well, I mean, you don't take into account or I mean, in the fire design, I don't know if we will actually, if that's foreseen in this lecture series, what actually you do is to consider reduced, or there's the method to account for the reduced cross-section method. What basically you are doing is to consider if you have the full cross-section of a beam with the width and the height. In the fire situation, of course, the wood burns and the cross-section actually reduces. So what is done that you have a certain charring rate of the timber, and depending on the fire duration, you actually have a reduced width and a reduced height of the beam after a certain period of fire. And of course, well, you could say in the fire situation, when you have a normal hole, what will happen if it's unprotected? If it's maybe unprotected, you have this situation here when we look at the cross section. So what will happen after a certain amount of fire? You will have a remaining cross section here and a remaining cross section here. So your size of the hole is increasing and your remaining cross section is decreasing. So you could assume a larger hole after a certain period of fire. But of course, that's not, I mean, there are no studies on the behavior of holes in a fire situation. If it's critical, you should try to reinforce it to protect also maybe the hole to avoid this charring here in these regions. You could put some external reinforcement that would definitely maybe help a bit to slow down or maintain the cross section a bit further. What is maybe most critical is if you have different rooms connected with a beam, with a hole, to of course avoid the fire spread. So you have to have a proper insulation material or like what's called separation. If you have piping running through, you have to seal all the entire hole to not have any spread of the fire or of smoke or other gases through the hole. So that would be, I think, crucial besides the structural point of view to avoid any spread of the fire. These are some of the questions. Let's see if there was anything in the discussion. Okay, yeah. Something we can have a look. Okay. Wait a second. I have to check the. Question regarding the K crack. I don't know if you refer to this one here. Okay, yes, that's true. Sorry, I mean, I use this maybe very standard value here of 0.67. But of course, you could yeah, assume a little bit higher value or higher value for the general situation where it's maybe protected. Yeah, that's true. Yeah, 0.67 is maybe sometimes yeah, safe and easy choice, but you can of course choose a high value depending on the situation. Yes. And I think the second question was the same. Yeah, that's true. So you can choose the higher value. Let's see. Actually, let's see what the result will be. I had here some made some calculations. If we have the yeah, you can maybe achieve a bit higher capacity. So you can make the whole, yeah, some millimeters more higher. So 82% remaining cross section instead of 86%. Not a big change, I would say. So around 80 something percent. Yeah, I think these are most of the question. I don't know if there's some. I think we can, yeah, take a break now, and we'll maybe in quarter past latest, Patrice will be back, or will then give the introduction to the project, or we'll say some words to that. Yeah, let's take 15 minutes break until quarter past 11, and then have a discussion about the project that will be handed out. Yeah, okay. See you later at quarter past 11. Yes,
det är Patrice här. Robert, do you hear me?
Yeah, perfect.
Is the sound good? No echo? Because I was on another meeting from another computer.
Okay, very good.
Så alla hör mig och ser min bild här. Ursäkta att jag inte kunde vara med tidigare idag. Jag sitter på andra möten på annan dator och sånt. Då ska jag försöka presentera projektuppgiften. En anledning till att det har dröjt med att vi laddar upp det är delvis interna lärarnas tillgänglighet, men det främsta är också att det var ungefär 40% som ville ha eget projekt och de har ändrats fram och tillbaka och jag har väntat på att göra den där färdiga listan med namn och alla projekt och ända tills imorgon fick jag faktiskt 2 mejl där folk först har sagt att de ville ha projekt från oss och nu har de ändrat sig. Så det här har gjort till att arbetet har fördröjts. Men nu är det bestämt. Vi har ju 6 veckor från och med nästa vecka, vecka 37, för att kunna göra det här. Så jag måste ikväll låsa in. Senaste på måndag kanske, för det är några som inte är här. Men allra senaste på måndag måste jag låsa in vem som har valt eller tilldelat vilket projekt. Så jag ska nu snabbt gå igenom de huvuddelarna innan jag laddar upp det här. Jag skulle ladda upp det, men jag tänkte jag kan se utifrån era reaktioner om det skulle bli någon kommentar, så justerar jag innan jag laddar upp. Robert, could you help me and check the questions and answers in case there are some important issues? I can revise the text before I upload the PDF after my, okay?
Yes, yeah.
Yeah, so I didn't upload it because I thought when I present it, some people might have some comments or suggestion, and I didn't want to rewrite and upload again. So at the end, depending on the questions and within 15 minutes or 10, if no comments, I will just upload it. Okej, då går jag tillbaka till svenska. Övergripande när det gäller redovisningskrav på första sidan. Och jag sa det första dagen vi började på kursen att vi utgår ifrån att ni kan redan det grundläggande med byggmekanik, statik, hållfasthetslära och sånt. Men det tål att upprepas, för några av lärarna var lite oroliga ifall det skulle börja komma frågor om hur man räknar moment och sånt. Och då ville jag bara repetera det här när det gäller saker som har att göra med strukturanalys. Det jag kallar för punkterna 1, 2 och 7. Det utgår vi ifrån att ni redan kan. Och då ska jag visa vilka punkter det handlar om här. Ni får skriva i kommentarerna om ni inte ser någonting, så får Robert säga det till mig. Så de punkter som är obligatoriska att redovisa, det är formalia som vi utgår att ni kan. En omslagssida, innehållsförteckning, ett inledande avsnitt där man förklarar lite grann vad det är för projekt. Ingångsdata som laster och geometri och sånt ska redovisas tydligt där i början. Och sen ska man motivera varför man valde en viss bärande stomme. Jag kommer att visa under bilagor senare de olika förslagen på bärande stommen, och så ska man diskutera kort och säga okej, det fanns den här möjligheten och den, men jag valde slutligen det här därför att, och så motiverar man. Och det här är valfritt. För samma husbyggnad eller bro eller vad det nu är för byggnad, så kan 10 olika ingenjörer ha 10 olika utformning av bärande stomme. Ursäkta att jag avbröt. Jag såg att jag fick nu igen ett nytt mail om att någon som vill ha projekt tilldelat av oss. Så ni ser, det blir av de där 40% som det är 30 personer som vill ha eget projekt, så har jag behövt bolla fram och tillbaka. Nu går jag tillbaka till det här. Så,
Patrice, could you zoom in a bit, make it a bit larger for the participants to read better the text?
The volume is not...
No, the size of your
okay, the size, okay.
I mean, just zoom in a bit, that, or like make it or whatever. Yeah, thanks.
Or even maybe I can do it like that. Okay, so then I can't show everything at once, but I show it like this. Okay, this way you see it properly, right? Robert, now you see it, everybody sees it properly?
Yeah, I think it works. Or maybe you can switch off these kind of marks, how it's called.
How about now?
No. If you go to start of your of the word, I mean on the left.
On the view.
No, just go to start to not have the dots for space and stuff and so on. But
sorry, wait a minute. People don't see properly still, or?
No, they see it good, but if you switch off this special signs, maybe it's better to read.
Yeah. All right. Okay. Sorry.
Yeah.
Sorry. So this way, yeah.
I think it's still.
Maybe it takes a minute to show.
Okay.
Let me do it like this and open it again.
Or for me, it's the same. Anyway, I think it's fun.
You still don't see it? Because I removed the... It's the thing in Word you are talking about, yeah?
Yeah.
It should have disappeared now. Oh.
Okay. For me, no change, but maybe just continue, please.
I see some questions here. I will see if someone is saying.
No. Okay. No.
We can see it. We can see it. People say, okay.
Yeah. Okay.
Okay. So I can go. I can continue. Yeah. Or.
Yeah. There was a question about this own project, but maybe you can just continue with your explanations.
Okay. I present the project first and then answer questions at the end. I think it's easier.
Yeah.
If you notice the question. So the first thing is the formalia. När det gäller att skriva en teknisk rapport så utgår jag ifrån att med eran bakgrund alla vet hur man skriver rapport, så det är det där med formalia. En viktig sak här är då att man ska motivera den valda bärande stommen. Och då måste man titta på minst 2 olika förslag. För att visa vad jag menar med 2 olika förslag kan jag visa snabbt några av projekten här. Här har vi det där skärmtaket, och då har vi olika förslag på hur man kan utforma pelaren eller takdelen. Flera stycken här. Och du går slutligen med bara ett av dem där. Kanske på pelaren så du väljer det som står som V här, och för takdelen kanske du väljer det som står som 3 här. Och sen säger du, jag hade de där förslagen och jag tittade på dem, och med den och den anledningen tyckte jag att jag ville gå vidare med de här valen. Så inte mer med det, men man måste visa att man vet att man kan välja olika förslag. Samma sak med bron här. Här är det hur man väljer lutningen på de där snedställda stöden. Där ska man också säga, okej, jag hade kunnat variera vinkeln på ett sätt eller annat, men till slut på grund av det och det så valde jag att köra med den här vinkeln. Och samma sak på hallbyggnad. Man har olika varianter och så kan man säga att jag hade olika möjligheter, men till slut valde jag det här och jag motiverade på det här sättet. Och det här är en vanlig ingenjörsiteration. Ingenjörer brukar, när man får ett förslag från en arkitekt på utformning eller geometri, plan och elevation, så brukar man skissa snabbt någonting där. Om inte beställaren redan har beställt vad det ska vara för stomme. Men oftast ska du som en konstruktör kunna titta på ett par alternativ och välja ditt bärande stomme. Så minst 2 förslag på bärande stomme och så ska man motivera varför man gick vidare. Och detta gäller både tak, skärm, hallbyggnad eller bro eller egen uppgift. Vidare om formalia, så ska man ha tydliga rubriker och redogöra för när man gör antaganden och förenklingar. Det här utgår vi också ifrån att man ska numrera sina figurer och tabeller. Och har man större ritningar, långa beräkningar och sånt, så ska man ha dem i bilagor. Är det en mindre ritning eller en kort beräkning på en halv A4 eller så, då kan den gå direkt i rapporten. Och allt det där kan ni. Punkt 2 kan ni också, det är strukturanalysen. Man sammanställer sina laster, snölast, vindlast, egen tyngd, trafiklast om det är en bro. Och så tar man fram reaktions- och momentkrafter på grund av yttre laster. Man gör sin lastnedräkning. Man lastkombinerar enligt Eurokoden 9091. Det kan ni också. Det som är nytt som ni ska göra nu på den här kursen börjar från punkt 3. Att göra gränstillstånd och infästningar och brytgränsstillstånd. Det är det som är nytt på den här kursen. Och den bärande stommen ska bestå huvudsakligen av trä naturligtvis. Ni kan välja K-virke, limträ, KL-trä sammansatt. Och ni kan kombinera med något annat material om det är motiverat och förklara varför. Och sen i bilagor ska man ange större ritningar, sedvanliga CAD-ritningar eller så. Större beräkningar, har man MATCAD som är flera sidor, långa Excel, de ska man ha i bilagor. Har man använt något 5-program för att ta fram reaktionskrafter och moment, så ska man kanske visa skärmdumpar av det programmet. Har man egna referenser och bilagor kan man visa det här också. Så det var det. Och sen ska man ha i rapporten en bakgrundinledning, står det där uppe. Och den där avsnitt med bakgrund eller inledning. Och där kan man då klippa och klistra från de där projektuppgiften som jag kommer att visa snart. Det här var grundförutsättningar för det här objektet och så vidare. Och sen kan man, om man så vill, formulera om med egna ord. Så det behöver inte vara mer komplicerat än så. För de som kanske har lite rostigt med byggmekanik och annat, till exempel eurokoder, så har jag lagt upp förslag på referensverk här. Det är de där byggkonstruktion och regel- och formelsamling. Det är byggkonstruktion enligt eurokod. Så det är bara att googla på nätet och köpa, eller också har ni dem redan. Eurokoderna känner ni till, EKS på Boverkets hemsida. Om någon har lite rostigt byggmekanik så finns det också. Ni kanske redan har det, eller också kan man själv skaffa det. Så listan med namn och projekt måste jag fastställa under eftermiddagen här. Jag har ett möte som börjar snart och efter det laddar jag upp det här förhoppningsvis före klockan 18-19. Och de som inte är med idag får återkomma till mig då på måndag så det blir låst. Men jag tror att jag ser att det är ungefär 60 som är här nu. Och då kommer jag att ladda upp majoriteten av de som lyssnar nu. Eller också får man mejla mig nu. Och efter klockan 4 gör jag färdig listan. Klockan 5, sorry. Efter mitt sista möte. Då gör jag listan färdig. Så, och då är det bilagor här med de där projekten. Bilaga 1, det är skärmtak. Vi skrev hela tiden bensinmack, men Roberto skrev tågstation här istället. Det spelar ingen roll. Konceptet är detsamma. Och då har man en enkel skiss på hur en elevation på skärmtak kan se ut här. Med givna mått så. Och sen har man på figur 2 ett antal exempel på hur den bärande stommen skulle kunna vara. Så, och det var den uppgiften. Och det står igen att konstruktionen ska huvudsakligen bestå av trä, men det går att kombinera. Det hade jag redan där. Vidare, vilka laster som gäller. Det är samma uppgift, skärmtak. Det finns givet här. Och det viktigaste, vad ska du göra? Ja, du väljer ett lämpligt bärverk där du motiverar med estetik, ekonomi och vad det nu är, eller krav från beställaren varför du valde det. Du gör skiss, du ritar plan, elevation, viktiga sektioner, detaljer och sånt. Och här, du gör strukturanalysen på sedvanligt sätt. Lastnedräkning, reaktionskrafter, moment och allt vad det heter. Och det som hör till den här kursen börjar här då. Du dimensionerar huvudbärverk i brott och brukstillstånd. Och någon sekundär del också då i brott och brukstillstånd. Och så ska man dimensionera ett par förband också. Och sen ska man göra en preliminär dimensionering av stabiliseringssystemet. Så det behöver inte vara en fullständig beräkning, utan en preliminär dimensionering. Så det här var projekt 1. Projekt 2, det är samma upplag. Det är bara bron och mått är givna här. Och andra förutsättningar och laster är givna här. Och vad du ska göra, det är samma upplägg som på förra. Med undantaget att för en bro så vill man också titta lite på vibrationer. Så tredje uppgiften, hallbyggnad. Där har vi också förslag på mått, yttermått, elevation. Du kan variera här. Det står höjd får vara max 12 meter. Och längd får vara minst 40 meter. Här står det då att längden var 60 i det här. Så du kan variera från 40 upp till 60 då. Som en längd. Och höjden kan du variera från 8 meter upp till max 12 meter. Och så är det 3 exempel på bärande stomme-system. Och du kan ha något annat. Det står många fler alternativ finns att välja. Du kan välja fritt. Det finns i våra handböcker. Det finns på annan litteratur. Du kanske har på ditt företag eller gjort någonting liknande på skolan tidigare. Och sen är det redovisningen. Och lasterna är givna där. Och vad du ska göra är samma som förra uppgiften. Så vad man ska göra är i stort sett samma oavsett vad uppgiften är. Det är liknande. Det är liknande steg i vad man ska göra. Så arbetsmängden, arbetsbelastningen blir ungefär densamma för alla. Och sen när man har valt ett eget projekt, eftersom jag har fått 10 olika förslag, det är omöjligt för mig att sitta och designa för varje en. Då har jag skrivit här, jag ser att jag har stavat fel här. Har du ett projekt som liknar uppgift 1, 2 eller 3 kan du börja med samma preliminära koncept, det vill säga plan, lösning och elevation. Har du en byggnad som hus eller lokal eller egen bro lägger du bara enkla motsatsskisser. Det behöver inte vara mer än någonting sånt. Två bilder som visar planlösning och som visar elevation på det egna projektet. Så 2 enkla skisser, och det här bör du göra snarast möjligt. Det gör man på 10 minuter, en halvtimme max. Om ni har egna projekt, de som har skickat med förslag vet ungefär redan vad de ville, så några har redan någonting som kan vara en skiss där, och då lägger man in det på några minuter. Annars får man fundera lite och kanske någon 20 minuter, en halvtimme, och lägga in det. Samma sak gäller förslag på utformning av den bärande stommen. Om du har ett projekt som liknar uppgift 1, 2 eller 3 ovan, kan du utgå från samma liknande bärande system. Har du en byggnad som hus eller lokal eller en egen bro, så lägger du in minst 2 olika förslag på bärande stommar och enkla skisser. Så, och för det egna projektet så är det ju, du hämtar lasterna, snö- och vindlaster hämtar du på Boverkets hemsida. Du lägger in din ort och så får du det. Jag kanske kan visa. Jag tror att ni kan det, men ändå. Här till exempel, om jag vill hämta vindlast från Stockholm, så skriver jag och hämta, så inga konstigheter. Jag utgår ifrån att ni kan det. Samma sak när det gäller egen tyngd på de material som du ska välja på den egna byggnaden. Det finns i EKS 11 eller i eurokoder på SIS hemsida. Och vad du ska göra, det är samma eller liknande upplägg som på de andra projektuppgifterna. Och så en preliminär dimensionering på ett stabiliserande system. Så som ni ser är det samma upplägg för alla uppgifter, och nu ska jag försöka svara på frågor. Om det finns. Ska se här. Jag tittar från min kollega vill också komma med på listan. Vilken lista vet jag inte. Det är någon som inte är här då. Och sen skulle man mejla vilket projekt man vill ha. Alla har ju, när de anmälde er på kursen, jag har den listan här med mig. Jag vill inte visa det här direkt eftersom det finns andra uppgifter som adresser och sånt. Så. Men alla som har gått som går den här kursen har redan i början sagt antingen att de ville ha skärmtak eller hallbyggnad eller bro eller egen uppgift, och så har de rangordnat. Så jag har det där här. Det som jag kommer att göra idag är att vi kan inte ha 60 som gör en skärmtak, och ni har rangordnat med 1, 2 eller 3. Så beroende på om det är 50 personer som vill ha skärmtak, då tittar jag på rangordningen, vad du har valt i första, och så kanske andra får då sitt andra val som var hallbyggnad, eller sitt tredje val som var bro. Det är så jag kommer att göra. Så den listan blir klar senast klockan 19. Jag kommer att låsa in nu på eftermiddagen klockan 16 de som fortfarande inte har lämnat information om eget projekt, för det är det som har gjort att jag inte har kunnat göra listan. Så det var den frågan. Skulle man mejla vilket projekt man vill ha? Var det svar på din fråga? Du hade redan när du anmälde dig på kursen lämnat några först. Ja, bra. Är det några fler frågor? Om inte så ska jag lämna över till Robert, och så laddar jag upp det här. Sen skapar jag en diskussionstråd på Canvas. Och då är det bra om jag kallar den diskussionstråden övriga frågor om projektuppgiften. Jag tror det är enklare att istället för att vi mejlar fram och tillbaka, det är enklare att ni ställer frågor på den diskussionstråden och vi lärare svarar där, och då kan alla ta del av det. 2 sista frågor här. Måste man nu i detta skede skicka in 2 stomförslag? Nej. Alltså, ni behöver inte skicka in någonting nu. Får se. Jag ska visa kursbeskrivningen. Vi hade här. Ni måste inte skicka, ingenting behöver skickas in förrän vecka 39. Det är bara om ni själva är osäkra på eran koncept, första övergripande måtten på planlösning och elevation, då kanske de kan bolla med oss. Annars är det ingenting som behöver skickas. Vecka 49 finns en frivillig delinlämning så att man kan få feedback av oss lärare, och om någonting är lite tokigt så kan vi påpeka det och sen gå vidare. Och sen är sista inlämningen, det är ju, ursäkta mig, det är 16 oktober. Så frivillig delinlämning vecka 39 och sen sista där i mitten av oktober. Så det var det. Escape. Låt mig gå ur det här. Så det var den frågan. Jag går tillbaka till frågorna. Så okej, det var den frågan. Den som frågade om man har eget projekt. Alltså även om du har eget projekt, om du gör en skiss för att visa grundmåtten på planlösning och höjd, så behöver du inte skicka nu. Du väljer bara dina egna mått på ditt projekt, och sen du kan ladda upp. Det är det jag har sagt till alla som har valt eget projekt. Ladda upp på hemsidan, och några har gjort det, andra inte har gjort det. Så när det gäller stomprojekteringen kan man också ladda upp ett system nu för att få synpunkter. Men det man börjar med i början behöver inte alltid vara det som är färdigt senare. Så det är inget. Är det svar på din fråga? Om man har eget projekt och om man måste skicka 2 förslag nu. Du måste inte. Är det okej? Den som frågade. Okej, tack. Får se om det är några fler frågor. Okej. Sista fråga, så lämnar jag en kvart till Robert om han har någonting mer att gå igenom med er. Inga fler frågor. Välkomna med fler frågor på diskussionstråden för projektuppgiften som jag kommer att lägga in på någon om. Okej, kan du repetera när vi får svar på våra egna projekt? För den som inte har ändrat sig 2-3 gånger och bara har skickat ett förslag på projekt, jag kommer bara att titta på om det finns övergripande mått på geometrin, och sen svarar jag ja. Jag kommer att, för de som har gjort det, det är ungefär 11 av 35. Jag kan svara på det ikväll när jag har laddat upp listan. Var det svar på frågan? Okej. Så om det inte är några fler frågor så tackar jag och önskar en trevlig helg, och så fortsatt bra med kursen resten av tiden, och så fortsätter vi diskutera på tråden på Canvas. Robert, I leave it to you now.
Yeah, thanks a lot, Patrice.
Wish you a nice weekend, and if we might talk later. I will upload now. There weren't so many special questions, so I will upload the assignment in a few minutes. Okay?
Yeah.
Okay.
No.
Thank you.
Very good.
Okay. Bye.
Bye. No, and I mean, if there are no more questions, I think we can also close this session now here. Yeah, or if there are more questions regarding also this week content, just write them in the canvas, and yeah, we will answer these comments or contact me directly. Yeah, but otherwise, I would also wish you or like to wish you a nice weekend. And,
okay, thank you.
Then see you.
And the people who have sent their project, their own project the last few days, de som har skickat egna projekt, när jag laddar upp listan klockan 19 kommer jag också att mejla till dem om att det är OK eller ändra måtten så det blir lite större eller någon sån detalj. Så klockan 19 idag, innan jag tar helg, kommer jag att svara till de ungefär 11 som redan har skickat ett eget projekt. Om de inte har ändrat sig. Det är några som har ändrat sig. Nu lämnar jag ifrån mig. Okej. Bye bye.
Okay. Yeah. Then have a good weekend, everyone, and yeah, see you in 2 weeks. Bye bye.